Okay, here is a situation where we have to find probabilities of these values when we have a normal distribution. This is read as x normally distributed with mean 20, and that's supposed to be the standard deviation, but here it's the variance. And we know that the variance is basically, variance of x is, if you take the square root of the variance, you're going to get the standard deviation. So for that, the standard deviation here is square root of 9, which is then 3 to the square. However, the standard deviation is 3, okay? So because it's read as x normally distributed with mean mu and standard deviation to the square. But when you take your standard deviation, you take just the sigma sign, not the square. Right, so what about this one? We want to find the probability, okay, of x being less than 24. So that's where we're going to standardize. What I mean by this, whenever you have x being less than 24, you're going to take it as a standardized normal distribution situation where you say you're going to go for x, first of all, being less than, okay, the observed value, which is 24, minus the mean mu. The mean is 20. And then you divide by the standard deviation, which is basically 3. We found the standard deviation. And so this is our answer basically. So therefore I'm going to get x being less than, take my calculator here, 24 minus 30, and you divide by 3, it's going to give you, 24 minus 20 divided by 3, that's going to give you 1.333 and so on. So, and it goes on forever. So now from here, when you standardize, okay, this is a normal distribution curve. Okay, and the mean is supposed to be 20 here. All right, I'm taking less than 24. So 24 is supposed to be somewhere here. So this is standardized. It's mapped onto the standard deviation normal distribution curve, where you've got the mean as 0, and this is z, and we're looking for some value here. Okay, and let's see. So what we're going to do, we're going to say that this z here is phi of this value, 1.333, and so on. So if you were to do this calculator, you go into the statistics mode, and you're going to take the first one, and the answer is 0.9087. Here we are. So you're going to get your answer as 0.90, let's say 909, okay, 8724 significant figures. That should be your answer. What about the second one? This one here, 18 less than x less than 23. So if you say probability of 18 being less than x being less than 23, basically what you mean is probability of this one here is greater than the other one. So probability of x being less than 23 minus the probability of x being less than 18. All right. If you were to understand what you're basically doing on a curve here, your normal standard deviation curve looks like this. Okay. And you've got the mean as 20. Okay. Now you're looking for 23 minus 18. So 18 will be somewhere below here. So let's say 18 is here, and let's say 23 is here. So all the area below 23 minus all the area below 18 is going to give you this one. So that's the area we're looking for, and that's our probability. So we are going to standardize. So that's going to become then probability of x being less than 23 minus the mean is 20, the mean mu, over the standard deviation, minus the probability of x being less than the time is 18 minus your mean 20 divided by standard deviation. From here, you're going to take it further. So this 23 minus all of that is 3, and 3 divided by 3 is 1. So probability of x being less than 1 minus the probability of x being less than 18 minus 20 is minus 2 over 3. So we can take the phi of 1 minus in brackets. If this is negative, what you do, you just take 1 minus the phi of 2 over 3. And if you were to work this out, you're going to get phi of 1 plus phi, because minus minus becomes plus. So plus phi of 2 over 3. And then minus the 1. So let's see. Phi of 1, which is this one, 0.84134 minus plus phi of 2 over 3. So again, do the same thing. 0.74751, and then minus the 1. So let's try and do all of that. And you'll see that the answer turns out to be 0.58885. So we can approximate the 0.589 to 3 significant figures. Right, now, so far what we've done is we've used this formula. So if you want to find any probability, you take the observed mean x minus the mean mu, and you divide by the standard deviation. So this is what we have used to get all these probabilities.